We might continue on with Phil. Certainly caused a fair bit of discussion this morning, so I think we're waiting with bated breath to see the continuing story. So I'll hand over to Phil.
All right, well, again, I appreciate your endurance. Being able to speak again is obviously an honour. What I'm going to do is probably spend 10, 15, 20 minutes with you, showing you some principles, kind of extending on from what we discussed this morning. Then I want to get into some interaction with you. I'm going to encourage you to challenge me on some of the topics that we've already discussed and some of the topics we are going to discuss here in the next few minutes. So without further ado, let's talk a little bit more about seeding. We've already talked about residue management, so we're not going to talk much about that anymore. I'm going to say one of your most important elements right here from a point of view of successful seeding is obviously going to be a sharp disc blade. It sounds obvious, but for some of you that have already discussed the topic of rocks today, rocks obviously have a huge impact on the sharpness of a blade, but be mindful that a sharp blade is critical to cut heavy, damp residue, and obviously cut the soil too, but when you've got heavy, damp residue on top of hard soil, it really becomes a challenge. So you've got a number of things that kick into play. Obviously, the sharpness of the blade is the primary consideration. Then it takes a lot of weight to push that blade into the ground. So the duller the blade, the more weight it takes. You've also got the interaction of speed. Most of the research will suggest that you get above about 7 or 8 kilometers an hour forward speeds. For every 1 or 2 kilometers an hour above that threshold, it will take an additional 10% downforce to push that blade into the ground. So the faster you go, the more downforce it takes. Okay? Be thinking about that also. So I don't know how well this photograph shows up. Probably not very well. We were driving down the field about 10 or 11K. Let me go to the next one, which may show up a little bit better. I'm not sure how well that shows up either. But what I'm showing is, let me go back to that one for just a minute. Okay, what I'm showing here is the interaction. We've got 3 different slides, 3 different interactions. The first one, let me start with this one, and then the others will make sense. This one is in an area of the field where the residue wasn't sprayed very well and a high concentration of chaff behind the header. And I'm going to suggest that trying to cut through chaff is probably one of the biggest challenges we have. I mean, obviously the physical loading of residue is a challenge, but even with moderate residue loads and high amounts of chaff, the chaff is extremely difficult to cut through. It's like trying to cut through braided wire with a pair of pliers compared to a single braid of wire. It just cuts a lot easier. So obviously spreading chaff is just as important. But obviously a lot of down pressure is required in addition to a sharp blade. The previous 2 images that didn't show it quite as well here, one of them was seeding into standing residue. Obviously, you're going to try and target seeding between the rows. We've discussed that. Everybody's on board with that. But seeding into standing residue, it seems like the disc blade filters its way between most of the stalks that are standing. So again, as we discussed earlier on, leaving as much residue standing as possible is going to help with cutting through the residue. I know down in South Australia a few years back, some of them guys were mowing and shredding residue, putting all of the residue or most of it on the soil surface, and it was a disaster trying to seed through it. So obviously what we're trying to avoid is hairpinning, okay? And in the States, different people have got different opinions. A lot of people look at humidity. People just look at the residue. People looking at when the header starts in the field. When the header starts cutting cereals, for example, assuming you're planting crops about the same time, it's going to be approximately the same time you can start a seeder. So if you can't cut a crop, it's going to be very difficult to cut through the residue, because obviously when the residue gets damper, it's really going to hairpin worse. So if there's one big drawback, in my opinion, of a disc machine, it's going to be the ability to run long periods of time unless the humidity is really low and the residue remains dry. As soon as the humidity starts picking up, that residue is going to start hairpinning something crazy. Even with a sharp blade, even with lots of down pressure, especially on some of your looser soils. I think there's going to be another speaker presenting here a little bit later on, seeding with disc seeders on sandy soils. It's going to push it in the ground. So again, having dry residue, or as dry a residue as practical, is going to be a huge issue. So what about residue managers? I know you've got the Arix one over here, and if it works for you, by all means continue with it. I think that's got some good key benefits. In my opinion, if you want to put a residue manager on a single disc seeder, here's a single disc seeder going this direction, so it's moving that direction. I've had better luck with a trailing row cleaner. So you've got basically an arm that extends forward of the disc blade with a pivoting point right here. So this is basically a trailing, floating residue manager. So instead of pushing it, I feel like the Arix, again, if it's working for you, continue on with it. But the Arix one is kind of like a wheelbarrow full of blocks, if you like. If you're going across loose ground and you keep raising up the handles on the wheelbarrow, at some point it's going to try and push you forward. And then it starts digging, then it starts throwing soil. And that's not what we're trying to do. We're trying not to move any soil at all. So a trailing residue manager, assuming you got room to extend it out front, and most seeders do, a trailing residue manager, in my opinion, works a lot better. So what we got right here is 13 or 15 fingers, approximately 3 inches finger to finger. Wider finger spacings generally moves residue better without moving soil. We're not trying to move any soil, okay? Now, some would argue if you want to incorporate some herbicides, maybe you want to move a little soil, so maybe you need a closer tine spacing. But for most environments that I work with, we're only trying to part residue. And sometimes only the most subtle movement of residue, just an inch or two to the side, or not even moving all of it, makes some huge impacts from a point of view of positive emergence of the following crop. So that's one configuration. There's lots of others on the market, but again, the trailing designs tend to follow the contours of the ground better. If there's any undulations at all in your field, I think this design is probably going to work a little bit better. So I did discuss earlier on pressing seeds. This is actually soybeans, treated soybeans, and this is where some of the designs start falling into problem categories, especially as the pins and bushing start getting a little bit more worn on some of the arms that suspend the disc openers. It's critically important that you press these seeds into the bottom of the seed slot. We talked about that a little bit when in the Q&A session earlier on, but it's one of the weaknesses of a lot of the hoe drills, like I mentioned earlier on. You're opening a slot, you've got moisture in the bottom of the slot. It's obviously the ideal scenario to press the seeds into moisture into the bottom of the slot, to actually engage or to press that seed into the bottom of the slot. Then ideally you want moisture above it, but at least you've got a chance of getting that seed to germinate. A lot of the hoe drills, they're absolutely just dropping a seed into a slot. There's dry soil falling in and around it. It may or may not emerge in that situation. So it's really only relevant when you're in more marginal moisture situations, but you need to be pressing positively those seeds into the slot. You've got a couple of options of doing that. There's various seed firmers on the market. You can either go with a wheel, a narrow wheel designed obviously to press the seed into the bottom of the seed slot, or some kind of plastic firming finger. Keaton seed firmers work very well on corn planters. I'm sure most everybody could adapt them to put them on your single disc seeders without a lot of trouble. Okay, you need to keep the pressure up on them. They make a mojo wire in the States, which is a spring assembly to push it down, to give it a little bit more down pressure, which is obviously important. But the principle of pressing seeds into the bottom of the seed slot is very important. Again, the Seraphim, the Case, the Deer all have a seed firming wheel. That's very important. Some of the other brands on the market don't, and that is going to be a weakness, again, when you're seeding in marginal moisture conditions, okay? So this is just an example of a wheel. It's been stopped for a little while. Some of the residue's blown into the seed slot, but basically an illustration of pressing seeds in a relatively small seed slot. This is a seed slot that's about 19 mil wide, so every 7.5 or 10-inch spacing ideally. We're really not moving any soil. I feel like some of the brands of seeder on the market, they're talking about minimal soil disturbance, when in reality, there's a lot more than I'd like to see. Now, you're going to get a little bit of soil movement, obviously, when you start closing the slot in from the side, but generally speaking, most of the single disc seeders used and configured properly, you're really not moving a lot of soil. You're leaving and maintaining as much residue on the soil surface for reduction of soil moisture losses and soil quality over time. You see on the top left-hand corner, again, that's the narrow gauge wheel. Obviously, what we're trying to do there is narrow up the hole opener to give us a relatively narrow shadow to be able to do inter-row seeding on narrow rows. What we're looking at here is, and there's a split down the middle. You've obviously on most of the seeders got different configurations to close. This is the rear arm on a single disc seeder. In this example, it's